Hi, welcome to our channel LetsMasterCS. Today we will be discussing on binary search, its application, its implementation and time complexity. Before starting, please like, share and subscribe to our channel and hit the bell icon for latest notifications. Let's get started. Binary search is very intuitive algorithm. Let us take an example. Suppose you are a class teacher of a class of 300 students. One day you have decided to take an exam. You have taken an exam, that means you have 300 copies to check. You have evaluated the copies. One day, one student of roll number 125 came to you and asked you for his copy or her copy. So what you will do? You will look for that specific copy one by one in the entire pile of copies? Certainly no. Now you will be choosing a value which is close to 125. Say you have chosen 121. Now you have to see the difference between the chosen value and what is your target value. Is the target value less than the chosen value? Then you will be going on the downward direction. If it is more than that, you will be going on the upward direction. Let us understand the same thing by an array, an integer array. Prior to proceeding with the binary search, you need to know that binary search has a prerequisite, that the array must be in sorted order. Let us take an example. This is an array of 13 numbers, all are in sorted order. There are total 0 to 12 cells. L stands for the lower bound, H stands for the upper bound or the highest bound or the highest index value, as you want to mention. Now suppose element to be searched is 32. What you need to do? You need to find the middle element of the entire array. How do I find the middle element? We will be using a simple formula, L plus H minus L divided by 2. What is the value of L? 0. That makes it 0 plus H minus L, that is 12 minus 0 by 2. 12 minus 0 by 2 means 12 by 2 means 6. 0 plus 6. So 6th location will be my middle element. So what is the value in the 6th location I am having? 50. Now the question is element to be searched, that is 32, is equal to 50? No. Is it greater than 50? No. Is it less than 50? Yes. Since 32 is less than 50, so we will be concentrating only on the left portion of the array, not on the right portion. So ignoring the right portion, my new high bound becomes 6 or the upper bound becomes 6. Now again we have to calculate for the middle element. Why we are repetitively calculating the middle element? Because binary search only can find the value from the middle portion. So again, if I want to calculate the middle portion, what I need to do? L plus H minus L by 2, that is 0 plus 6 minus 0 by 2. 6 minus 0 by 2 means 6 by 2 means 3. So 0 plus 3. So this becomes my middle element. Now is the value of the middle element is equals to 32? No. Is the value of the middle element is greater than 32? No. Is the value of the middle element is less than 32? Yes. So since the value of the element to be searched is greater than the middle element, so we will be looking in the right hand side direction. So we will be ignoring the left hand side and just the previous way, how from 12 H has been shifted to 6, same way 0 will be shifted to 3. So again we have to calculate for the middle element. If I am calculating for the middle element, what I have to do? L plus h minus l by 2. So L value is 3 plus h minus L means 6 minus 3 by 2. 6 minus 3 means 3 by 2. 3 by 2 means 1.5. So 3 plus L plus, so 3 plus 1.5 means 4.5. Can we have an index value with 4.5? Certainly not. So what we need to do, we either need to take it as 4 or 5. Now this is the solo discretion of the programmer, how they want to take the fractional values. If they want to take it as a lower floor value or upper ceiling value, means they can either take 4 or either take 5, means the 1.5 which they are getting can be converted into 1 or can be scaled up to 2. So that value is being added up with 3 and finally we can get the middle value. For this particular example, I have chosen the lower floor value, means I will be, instead of considering 1.5, I will be considering 1. So 3 plus 1 makes it 4. So that is my new middle value. Now again the question is, the value in the middle element is matching with our key element or the element to be searched? Yes, we have found it. So that is how the binary search operates. To perform this search, we have the average time complexity as order of log n base 2. Now since we are dividing into two halves the array and we are considering only one half at a specific instance of time, that's why log base 2, and the base case is order of 1, because if I go to the first example, see, if the element to be searched is not 32, is 50, then at the very first iteration only I will be getting the value 32. So that's why the best case time complexity is order of 1. Now let's code binary search. There are two ways of programming binary search. One is iterative method, one is recursive method. In our program we will be looking for the recursive method only. Now implement the binary search using C. Let's get started. So first thing first, hash include stdio.h, then int recursive binary search, int array, int start index. This will help us to identify the lower bound. Int end index. This will help us to identify the upper bound. Int element. This will be helping us to identify the element to be searched. Now since after successful searching of the element we will be returning the address location, that where exactly the elements are located, that's why we have introduced this as the recursive function has a return type of int. If end index is greater than equals to start index, that means we have not traversed the entire array. Int, and the line number 4 means we have not traversed the entire array, and if we have traversed the entire array and we still did not found the element to be searched, then, or you still did not find the element to be searched, then the this will help us to identify that whether the element exists in the list or not. int middle equals to start index so we have to actually formulate the formula. So what we can do, we can have the start index, the upper bound, that is start index plus end index minus start index divide by 2 semicolon. So this is the way we will be doing it. So this makes it the division, the subtraction of the upper bound minus the lower bound, and whatever the value is being generated, that has to be added up with the start index to get the exact middle position. If array middle equals to the element needs to be searched. Only one thing we have to remember, that whenever we are implementing binary search, the element can only be found at the mid position. Element, okay, then return middle. Okay, so we have evaluated and checked with the perfect parameter if the element is found at the mid position, but this is an ideal case, we may not found always. So if array middle is greater than the element, that means the element to be searched is a lower value or a lesser value than the value which is available at the midpoint. So what we need to do, we need to traverse on the left hand side. So if we want to traverse on the left hand side, then what will be our observation? Our observation will be our upper bound need to be equal to or less than equal to the middle value. Okay, so what we need to do now, we have to make a recursive call. Start index and the array value remains same. If you look it very carefully in the basic structure, we have declared it as a end index. So this end index value will be middle minus 1 comma the element value to be searched. Okay, now why this middle minus 1? Because middle value already we are checking. So if any value is less than the middle, obviously we have to exclude the middle one. Return, so I will not type it again, I will just copy and paste it. See, okay. Now if the value of the now the previous case, this particular line states me, the line number 10 tells me that if the element is less than the middle value. Now we have to think that if the element is greater than the middle value. Okay, so if that is the case, so let me put a else part over here, else. So if that is the case, then what we have to do, we have to check for our start index. Okay, so what we have to make the changes in our start index. Unlike the previous one, when the previous one the end index was used to updated, over here the start index needs to be updated, and it will be middle plus 1. Okay, now after doing everything, we will be, so there can be a case where the value could not be found. So in that case we will be returning -1 as a default value. Okay, now int main, put some braces. Now let's declare the array. So I am declaring it over here. You can obviously take the dynamic array allocation or the dynamic values or the runtime values. (16, 56, 70, 71 also will do. So the element to be the total number of length is say 7. That will help us to control the loop. Or the highest number of the highest value of the upper bound will help us to implement the upper bound. Int element, so element will be, suppose I want to look for 9, so 9. So if it is being found, so found equals to recursive binary search. Now let us put the parameters. Array name is array, then followed by the start index value, that is 0, followed by the upper index value. So there are total n 7 values. So 1, 4, 7, 9, 16, 56, 70, total 7 values. So the index, if it starts from 0, it will go to n-1. Then element, then if found, so we have to check whether the value which is being returned to the found variable is -1 or not. If the value is equals to -1, then we will be stating that printf element is not found. Okay, so let's put some semicolon at the end. Done. Else printf element found at, so we have to kind of put the value where we have found the element. So what we should be putting, the value of the found. Okay, so that's it. Since I have given int main, so I will be putting return 0. So that's it. The name has been misspelled. Code space, we was able to run this code, and we can see the element could be found at location number 3. Okay, so line 9 is found at location number 3 because this is 0, 1, 2 and 3. That's why we can say that the 9 is found at location number 3. Okay, this is how we can program the binary search, and we can evaluate the execute it. So this is called the recursive approach. This is also called the divide and conquer approach. Thank you for watching. Please like, share and subscribe to our channel, and hit the bell icon for the latest notifications.